officially, here we are starting the section. So yeah, use Perforce if you haven't already. You won't need it for this first submission. You're only going to need that, not for the submission tonight. Tonight's submission is really going to be done via LMS, and it's just going to be either text that you just literally paste into the submission on the server, on LMS. Let's see, let me pull up here again. Okay, so here we are over in here, and we're going to go to content, and this is the submission point from, I think, hopefully I've set it up for both classes. If I didn't, boy, I feel foolish, but I think I have it set for both sections. Okay, so we're going to go in courses, and we are the second session of Intro to Game Programming, and within here, if you look up submissions, you will see that there's a little LMS submission point in there with some reminders. Now, one of the things about the design documents, and certainly starting out, I like to use this as an opportunity to sort of get to know how you think, as well as kind of hopefully exert a little bit of influence and some good practices and things in terms of design. But this isn't intro to game design necessarily. This isn't really a software engineering course. It's a little bit of that, but it's kind of a balance. So I'm going to let hopefully a little bit of your personality come through and get a feeling for how much instruction or how much detail you think you need when it comes to actually implementing something. But I do expect to see a reasonable document. Now, the design, as it says here, it says due tonight. So it's due tonight just before midnight. It's worth 3 points. 3 points. So you can think of those 3 points as sort of like one being for the overall kind of game concept in terms of a narrative. What are you going to do? What is the situation? What is the world? What's the real setting of the game and so on. Less about the mechanics and more about like the overall kind of view of the world. And the other parts are really going to be more about sort of the mechanics of it. One saying, all right, how are you meeting the suggested criteria in terms of using the directional buttons, an up, down, north, south kind of thing. You'll see there's even some things in here mentioning about, are you using the straightforward version, which most people do, an on-screen directional pad made up of Unity UI buttons that have a move up, down, left, and right, or north, south, east, and west. Or you might want to go some other, if you're already used to using Unity and you want to be tricky, you could do something like, okay, I want to have a turn left and right and then move forward, backward. So you actually turn and then move, for example, right? That's an example of sort of like making a character controller decision. How do you control your character's movement? We'll talk more about actual character controllers as we get into real games later. But remember that this is supposed to be a sort of text-based game. And by text-based, I mean Unity UI-based. Everything is going to be triggered by an action that you perform in the Unity UI, and that action is generally going to be considered sort of you taking a turn. Right? So this isn't your typical real-time action game. It's more like you click a button, something happens, you have to kind of inform the user, give the player enough information about what happened to the state in the game. What did music get louder? Did they smell something coming from the west? Did they hear a breeze? Did they feel a chilling presence? Sort of thing, back and forth as they go through the game. And there should be things like, okay, at some point you have to tell the player, they reached the constraints of the world, right? There's not a visible world in this game. It's supposed to be sort of a conceptual, explained to the user, through a narrative means. Okay, you bump your head against the cold stone wall to the north. Okay, so you can't go that way further, and that somehow then it limits their motion, so they can't go beyond that, and somehow we'll have to implement a crude sort of collision detection system from scratch, right? Some of the things we're going to do in this version, this program, this module, this level, whatever you want to refer to it as, is going to be kind of a little bit of brute force and getting a feel for like, boy, I'm glad that there are really built-in functions later on in Unity, because I could imagine how complicated this would be if we did it overall, right? So this is kind of introducing the sandbox version of some things like that. So sometimes it may seem arbitrary, and those of you who are more familiar with Unity might say, well, why don't I just go ahead and do this? The reason is so that you can kind of understand what Unity is doing underneath those things, right? So you know how a circle collider fundamentally works and how some of the distance stuff fundamentally works. So remember that. Okay. So it's a UI-based game. There should be no graphical indication of motion, right? Because there's going to be no game object that actually moves around. It's all going to be UI. However, we may have UI elements that are graphical. You might say, you see, if we get fancy, say you encountered a key and show them a picture of a key as part of the UI. Maybe you want to get fancy and have a little bit of a kind of graphical inventory system that's in your UI. All right, that's cool. That would be interesting. But remember, we're doing everything through a UI, through a heads-up display, not by looking in the real world. The only thing that we want to have in the real world is sort of the sound, right? So there will be some kind of a little bit of sort of real-time interaction with sound potentially. If we bump into the wall, we play a sound. We step on a twig, we play a sound, right? So we'll have some of that. That's the idea. There may be background music that plays the whole time. There may be a heartbeat that gets louder as we approach the who knows what it is that we're approaching that the heartbeat sound gets louder for, right? So I've seen it all. I actually haven't seen it. I'm looking forward to seeing how you interpret some of these challenges here, right? So think about, here's some questions. What is the situation? What are the constraints? What is the challenge for the player? Do they have to find a key? Do they have to find dog food? Do they have to find a weapon in order to break open a door? And so on, right? So you do this in order to do that. So sort of like, have to get a feeling for something. Very, very simple. Don't think of anything more than a few steps, 1, 2, 3 kind of steps, right? But something like that. There should be something in the game that is sort of a managed resource as well. So if you look at the examples that I have put up there, there's usually like a flashlight or a camera flash or batteries for your radio. And you can kind of tell, okay, as long as you're listening to the radio, the station gets louder. But, if you have the radio turned on for too many turns, the batteries run down. So you have to kind of keep track. It's sort of like having health points. All right, you could have health points as well. That might count as a managed resource, right? I've seen people do it like oxygen tanks and health points or battery charges or, like I said, however you want to take it. Don't get too carried away. Keep it simple, right? We're just starting out, and it's really about how we're going to kind of hook that simple design to the game itself. Okay. The other point. So I said those 2 points, about one for the mechanics, one for the overall game. And the third one is going to be how well you describe it in terms of, could someone else, can I imagine that you could give this to somebody else and that they could design from it, right? So it's a matter of kind of completeness and thoroughness, right? Not necessarily the point where you have to define the whole project again, because you can assume that whoever got this, if you did hand it to someone, they're also in this class and they know the general goals of the assignment, right? But enough about it so that you can really kind of get your unique points across to someone else potentially if you wanted somebody else to build it. Not that anyone's going to build it, but you should always kind of create your designs with that in mind. It helps you to overcome any assumptions, right? If you just say, all right, try to be explaining it to somebody else. Use a bit of rubber duck design where you kind of to explain it to a rubber duck sitting on your desk. Think of it that way, right? Rubber duck debugging is a more common term. We'll talk a little bit about that, I guess, in the future. All right, so the deliverable should be no more than a page of text, perhaps with a simple kind of screen layout if you want. If you want to scratch something down, if you want to draw a couple of boxes saying, okay, here's where the directional pad is, here's where the text readout is, here's a couple of additional buttons that do X, Y, and Z, here's a box that I'm going to show them the items that they encountered or something like that. All right, think of it like that. Submit it as a PDF or Word doc, or you can just paste it directly into the assignment. If you click on Project 1 Design, for example, you'll get to the assignment, you'll see the points, you see the due date, and you can either just put stuff in there, write submission, or attach files, one or the other. Good to go. Any questions? Whew. Oh, we're at 30 of 30. Yes. Mm-hmm. Um, does it work out to say that it has to be submitted within the next 9 hours and 40 minutes and be here for class? Right, but it probably it will say that would be Eastern Standard Time, right? So it's due midnight Eastern Standard Time officially. So it's not going to mark it as late or anything until midnight Eastern Standard Time, because of the time zone difference and the fact that you're in the middle of the night there. Um, I can offer some. If you'd rather, I will record today's lecture, and or I definitely have already a recording of this morning's lecture. So the same thing will be covered if you're. You know, I can see that it would be tough if you're going to be if it's already 11 o'clock at night and you don't want to be that late. I'll leave it up to you in terms of things. If you want to catch up on the lecture later, or if you do have time to work out the rest later. All right. So, okay, a few questions. Is this purely text-based? It is purely UI-based, and the majority of how you express to the player, to the user, should be in terms of text. You should rely on graphics minimally, and usually just in the terms of buttons. Usually I don't even allow for, graphical, items. I would say, okay, if you want to show an item on the screen, that's fine. But do not indicate to the user their location in any way other than talking them through it, texting, giving them text. So is there any particular way or restriction on how we can internally represent where the player resides in the game world? We will discuss that, not today, but as part of a lecture to say, okay, we'll introduce game objects and their transforms, and we'll actually use some of the built-in things in the system to do that. But you should assume, if you want to make an assumption, that there will be some sort of data structure that will hold a position in terms of it as an X and a Y space location in the world, right? So we're not going to be positions on a grid or within a matrix or something like that. We're going to be X and Y locations within a world, and we'll talk about that as we introduce some of the topics of 2D math, 3D math, how we're going to move around in the world. Okay, does that make sense? So minimally graphical, right, is the idea. Okay, all right. So whether or not you define within your component your own X and Y, or we rely on a transform within the game object, we'll talk about doing that different ways. But that's the general idea, right? We don't want to necessarily have things moving around on the screen. We may accidentally have things moving around in the game world, but we're not going to really use that as the feedback to the user. I know it sounds a little hokey if you're used to doing things in Unity, but trust me, it's worth it. Okay. It's like wax on, wax off, learning karate through the Karate Kid. It's, everybody's watching, at least I'm sure you get the cliche because everybody's watching Cobra Kai, so you should understand the Miyagi way of learning Unity. Something like that. I don't know, I just made that up. Okay. Done with the project. Done with talking about the project. Cobra Kai. Oh, yeah. Why does everybody take turns on being just a terrible people in Cobra Kai? That's the thing about it. It's like every week, just somebody, if not everybody, is suddenly a terrible person. That's just what always happens. Yeah, it's just terrible. Okay, all right. So let's hop over though. Let's get to the real serious stuff, and we're gonna jump over to our day 3 and really talk about programming. Now, last time we left off with just a tiny. We had a shred of programming in terms of having our game manager in Unity that had a game manager script in here, and at the time, I'm going to go ahead and I guess I'll pay no attention to these additional functions. We did these this morning. But the start function, or the start method, which we'll talk about methods versus functions in a second, the start method or start event within our game manager script was the first thing we wrote, and it was a simple hello world, which showed up here in the console. All All right, so the console is going to be our friend when it comes to these print functions, which also stands for, it's basically a debug output, a debug log. So whenever we see print or we see using the console, that's really a debugging tool. So that's one more thing worth mentioning too about the project. Even though we call it the text-based adventure, you should not be using print statements other than as debugging tools for yourself. All right? I shouldn't have to look in the console window to figure out what's going on in the game. Now, I know we had discussions about it this morning about that being a thing. If you want to have a console window, if you want to have output all the time, the text feedback you're going to give to the user, it's going to be through your own implementation of that text, and that's going to be what you're presenting in the Unity UI elements, the text or the Text Mesh Pro text elements there. All right, so console is for debugging, right? Remember that. It's your friend, though. It's really, really super useful. And here we are in Unity 2021 again. All right, now back to here. Okay. All righty. So today we're going to talk mostly about C# and also kind of, some considerations for how we use C#, what particular features of C# we use within Unity, what its strengths and weaknesses are specifically with regards to Unity, and as a scripting language versus a development language. So sort of like scripting in C# versus programming or coding or developing in C#. A little bit of that. All right, just quick refresher. In terms of objects and things, we have our game objects, which are the things in our game that we're going to be building, the nouns. The independent objects, they can be visible, they can be invisible. They might be things like a camera, a light, terrain, vehicles, objects, obstacles, players, sources of audio, that sort of thing. They are collections. Ultimately, they become collections of components. The components are where the actual features get implemented. By adding these components to our game objects, they pick up functionality. They become more useful in the game. All right, so everything we've placed so far, whether it's a camera, we'll actually have a camera component and a transform component. Whether it's a light, we had some simple lights in there that are automatically put in that had an actual light component on it, which gave it its functionality. Even our game manager was just an empty game object that we put a game manager script component on. Right, so things like transforms, renderers, colliders, scripts, whether they be visual scripts or C# scripts, they are the components, right? Now, within components, we will have the fields and properties or data, variables, right? The adjectives, all those attributes that are contained within the components, the data we actually work in there, the data that is generally encapsulated kind of inside of our objects, things that the object knows about itself that are important and kind of local to itself, right? The location, the health, the ammo, the size, the scale, the item you're currently carrying, etc. All right. Then we have the functions or methods that are the rules or verbs. When they are methods, especially, they are within a component, right? In object-oriented world, we want as much functionality to be within the objects as possible, and then we get more complex as we have objects sort of interact with one another through their methods, through the kind of the interfaces that they present to one another, right? They can call each other's methods and occasionally reference each other's properties when we need to, right? So methods and functions, things like move, fly, wrap around, block, aim, etc. Now, to use another analogy that I like at this point, imagine driving a car. You press the brake, okay? So your interface to the brakes, the way you call the brake function is by pushing down on the brake with your foot. You don't actually interact with the brake pads or the calipers, the rotors, all that kind of stuff. You don't touch those. You don't even know about those, right? Those are the data, the things underneath, maybe other functions, private and things. You're not working with those. You're working at a higher level. You're just calling the brake method, right? As the player even, you may be the player object and you're running the car. And so the player calls the brake method of the car in order to get the car to stop, right? It doesn't go in and change the speed or squeeze the calipers, whatever, right? Now, events are the conditions. These are the things that occasionally the system, often the system and sometimes the other parts of the architecture, will cause a condition to happen. Some circumstance that we care about triggering a particular rule. Hit the brakes, right? There's going to be some condition. You see something, you hit the brakes. It's time to update the graphics on the screen, so therefore you flip to the next sprite in the animated flipbook, right? That sort of thing. When a button is pressed, do this, right? When two objects touch or collide, do this. On every frame update, do that. Every second, do this, and so on. All right. So to get something done, we call a function, or we call a method or procedure. Think of these things. They are just the code. We call a routine of some sort, right? These functions will have a name, just like here we have Unity has a built-in function print, and print is not part of any particular object or component. It actually is sort of a system-level library. It's part of debug. So debug.log. Print is a shortcut for debug.log, right? So it has its own place that it lives, but not within any particular game object or component that's actually in your scene. It's a system-level component or object, really system-level thing there. So it has its name, and between the parentheses are a way to indicate that this function takes arguments, or all functions will have parentheses saying, okay, that's how we know we're invoking a function. And the data that we're going to pass to it is in here, right? The arguments, the data that we pass into the function. So in the case of print, for example, it expects a string here, right? Sometimes we'll have functions that might take one or more, or maybe even a dynamic number. Maybe they have just, depending on how many parameters you pass, what type of parameters you pass, you may have different functions that wind up being called. We'll talk about that in terms of object-oriented techniques, polymorphism, cool buzzword for later. So we have a name, we have the arguments, we close the parentheses, and we have a semicolon. The semicolon tells the compiler, tells the system that we have reached the end of the command. We have one complete statement here, execute this. So you can kind of think of the semicolon as being, all right, as it's reading through or as it's compiling, it says, okay, statement done, time, you have enough information about what's going on in this line to do it, to do whatever it is that you need to do. All right. So C# is an object-oriented programming language. So often we think of the data and the methods, or the data and the functions, the variables and the functions, as more properties of an object and the methods of communicating with the object. So we'll often hear these terms, properties and methods. So C# is an object-oriented programming language. Everything in C#, and this is a generalization. Don't hold, I'm not going to appear before Congress to swear to this in all circumstances, but for all practical purposes, everything in C# should be or is associated with objects that are described via classes or structures, right? Or structs, and we're not going to use structs much, but I feel like I have to mention them, or else I just, part of me feels like I'm not being honest. So, but normally we're going to be using classes. We may use structures or structs that contain properties and methods. For example, in real life, a car is an object. A car has certain properties, such as its weight, its color, so on. And then it has methods, such as driving and braking, right? So properties, we think of more as the data. Methods, they are the rules or the actions, right? The class itself, the class definition, is like an object's recipe or blueprint for creating objects of a certain type. Just defining a class doesn't give you an object. You have to then, once you've defined a class, you then have to declare a variable of that type, of that class type. So in and of itself, yes, an actual object is sort of like a variable. It is a named instance of a class that the system creates for us, right? You'll see, we'll start to say, give me a new object, a new component, whatever. So we're gonna instantiate these things. We're gonna say, okay, cook me something from this recipe, and then we're gonna have the actual object, right? So the classes, the class scripts are the things that are gonna define these things, give us these blueprints, and then we wind up with the objects. So an object is the basic unit of object-oriented programming. No surprise there. Patterned after this idea of having real-life entities that stand on their own, right? They have everything they need to kind of survive within whatever world they operate in, right? A typical C# program can create many objects interacting with one another by usually invoking one another's methods. An object normally consists of some sort of state, all the attributes and properties and so on that are inside, right? So the state of the object is what the current variables, what the current data sort of contains at the moment, right? The behavior represented by the methods of the object. You invoke some sort of behavior, you trigger some sort of behavior. It reflects the response of an object to other objects, the response of an object with other objects. That suddenly feels awkward to me, but that's the idea, right? It's all about behavior and action, actually performing a set of operations in response to something. And the other thing about an object, you have to have some way of referring to an object. Once you create one, you instantiate it, you construct it, you declare it, you're going to have some way that you're going to then refer to it. So like I said, it's sort of like a named variable, basically, right? You can have a name for any particular object that you create. Maybe it's the game manager, or maybe it is Bob, or maybe it is my object. Some name, some way of actually referring to the object, this particular object that was created from this particular blueprint, right? So we'll be referring to objects through their variable names, right? They are effectively variables. They're those containers for an object or a reference to an object. There's lots of terms in computer science, and every computing language seems to offer slightly different takes on it. So just to warn you, I tend to be a little bit loose on here until it comes to, if you want to say, okay, well, when would I really do, what's the difference between those? And then we can kind of get down into the nitty gritty. But methods versus functions. Normally, methods are functions that belong to an object. Properties and fields and attributes. Now we're talking about more specific, basically, variables and data that belong to an object. Right? Sometimes a property is sort of the way that the attributes of an object are presented, whereas a field might be something more kind of specific, or a field within an object is something that is like, more lower level and hidden. It might be hidden from the rest of the world and so on. So that you see this example down here where we might have a health field, which is a private attribute, versus a health property, which is a public attribute, which is available to the world to see, as opposed to maybe health is that you've kind of collapsed everything down and said, oh, okay, health is just this number from 1 to 10. But what that really represents is some complex formula that has a combination of metabolism and food and armor class and so on and so on and so on, right? So maybe to the world, it presents itself as health, capital H. But inside, it's actually a combination of a bunch of private attributes, private little fields that only the object knows about. And then it will say, run this formula when someone actually asks for health, right? That's kind of a way of seeing what that is. So there, we would talk about the health as a property at a higher level, and then maybe there are things that health derives or is, calculated from at a lower level, for example, right? So a field describes a bit of data within an object. Is recommended it is accessed through a property that has a prescribed method for getting and setting it rather than directly accessing it, especially if you are doing something a little bit more sophisticated where, you're, like I said, health is more than just a single number, right? So are fields private members and properties public members? Not at all. You can mix and match those. It's sort of, it's by convention. Well, I guess we can kind of say, yeah, they are. I could say, yes, for our purposes, they are. So properties usually rely on underlying private members, private fields. So these are conceptual things, though, right? There's no such thing. You're never going to declare officially like a member or a field or a property. You don't declare those, right? You declare an int and you say, is that int private or public? That's really what you do. The bit of magic that's represented on this slide is really this mechanism here, this getting and setting, which is a feature. Hello? Oh, someone must have accidentally had a mic on. So there is this get and set mechanism that allows us to kind of implement this property versus field system, but it's all, it can be very conceptual, and it's sort of up to you. Can you get by without? Can you just make everything data? Can you make just everything member variables or attribute? Yeah, sure. You don't have to get as fancy as this, but it's good programming practice to kind of do some of these things, right? You'll find you'll write cleaner code. It'll be easier to understand and so on. Okay. So in real life, you'll likely see a mix of these terms, property, attribute, field, and we'll, in a lot of cases, use, we're going to generically refer to the data in the object, because fundamentally, that's what it is. It's the data within the object, whether we get fancy or not. You'll see the value of doing things like this as we get into more complicated things when, for example, if you wanted to make sure that anytime someone added to the score, it also shows up on the screen, right? There are reasons. So if you change the score property, not only is it going to add to a number, it's also going to make sure that number's on the screen. It's also going to make sure that that is reflected in the health, maybe it's, and so on, right? So be prepared for certain things being kind of generic, but then as we get into specific features that help you to kind of understand the power of some of the underlying things in the language. So is the proper syntax of get and set with arrows after them? There are a couple of different ways to do this. This is the one-line version, right? So don't worry about this for now, but this is one way of doing it. Right? There's a couple other ones where they're not just one-line simple versions, right? They can be encapsulated. They can be, other versions of that. I think that's right. I have to remind myself. Do you use properties to define fields? I would say no. Fields are usually used within properties, right? That's kind of how it's, properties is supposed to be. So this would be the property, and the health underscore health is the fields that are used inside of this health property, right? So think of properties generally as being a publicly available access point for a particular piece of data. And whether it's actually that piece of data or it's a getter function for some group of data, that's kind of how it is, right? So think of the property as a way to appropriately access data through a public way, right? And like I said, so those of you who are getting a little nervous now, you can get away without, without getting nearly as nitty gritty about a lot of these concepts, right? So go as far into them as you like. We will revisit these as part of different examples, right? So don't worry too much about getting the global concept here. Just know that these things exist and know that there are design considerations and conceptual considerations when you say, okay, is this variable, is it something that just this object needs, something this component needs, something the system really needs to know about? And there'll be things in the language that will help us to present those in the best possible ways. All right, here's some more. Here's the other example. Fields versus properties, getting and setting accessors, right? So you can do this way as well, right? So if we're not doing a single line version, we could say, okay, C# etiquette, leave fields as private, there's the nitty gritty things, properties as the means of accessing the data, right? So here's another way of doing it if you have a little bit more of a complex setter function, right? For example, if you have months, a month field, you don't want months to be, you don't want someone assigning 14 to the month, because there is no 14th month, right? So we can use getters and setters so that we can have some enforcement to that actual set, where we say, okay, when you try to set that value, I validate it before actually setting it. That's like one of the key reasons you use properties, so you can do things like validate data that you're being given. What is a backing store? Okay, the backing store we'll just refer to. Oh, I should have left that out. This is it's a way to refer to this. This is the storage of the actual field in the object itself, right? It's just the private. Think of this as the field, right? Month is the field. Backing store is just another term for that, right? It's the field that backs up this property, right? So I don't know what example I grabbed that one from, where I had that. But this is just another way of saying the field, right? The field is the background data that it really inside uses, right? Okay. Classes and structs. So we talked classes, basically initial value, not an initial value. It is the value that the object itself has internally, right? It would be the brake calipers. It'd be the actual thing that is being used, but you want to make sure, like in this example, month is the thing that really gets used. That's the real value. This capital M month is just the property, is just a way of accessing this field appropriately with some enforced validation and a way of tracking to say, okay, it has been accessed, right? It's not an initial value. We'll talk about initial values in general when it comes to variables, but it's a hidden private actual data that is protected from the real world by enforcing. When you do want to access it, you have to go through the property, or if you want to get even fancier, or you could write some method of interacting with that property or set of fields. Okay. Let's see. So it's an initial value, or the value that the functions use. It's really the value that the objects use, right? It's the object. The object knows everything about its own internal state, so it uses everything there. The object wants to be careful what it tells the world about. It's like, your social security number. You don't want to tell everybody in the world, and you don't want everybody going through your wallet anytime you go to a website. You only let them know because they have to go through some appropriate mechanism, perhaps, ask you to use it, and then you tell them as much as you want. You give them, say, just the last 4 digits when they ask to see your social security number, right? You have something like that. Or someone says, oh, let me put money in your wallet. You're like, whoa, hey, okay, I have a give me money function, but the first thing that really happens in the give me money function is I look at the money, I make sure it's not counterfeit, I look, to see that it's all cool. When I do that, okay, then I say, all right, now I can put it in my wallet, right? When I know the money is good. So it's that sort of thing. All right, once you accept it and the object digests it, then it's all good. So, advanced topic, we'll come back to that. We'll see it in use. It'll make more sense. So classes are the main thing we're going to use, but structures exist as well. And they're almost, in some cases, they're fairly interchangeable. They both have this data in them. They both have methods in them. They are basically 2 basic constructs of the common type system in C#. Each one is essentially a data structure that encapsulates a set of data and behaviors, methods and properties that belong together as some sort of logical functional unit, right? A car, the wheel, the enemy, whatever. It could be, you could define things in terms of structs or in terms of classes. There's, we usually use classes because they are more flexible and global. They are, for those of you who are more fluid with different computing language or fluent with different computing languages, you may have heard of something called the stack versus the heap. The heap is kind of all the memory that's accessible to your program, whereas the stack is usually a smaller operating space that the program uses to kind of keep things local and fast and so on. So you have this programming stack versus the heap, which is like any memory. So normally classes are on the heap, so they can be any size, and we can have as many of them as we want, and they're really flexible and so on. But there might be a little bit of a performance penalty versus using something which is a struct on the local stack. But for our purposes for right now, and in general, classes are the thing to use, right? Because they are more full-fledged objects in that, you know, we don't have as many constraints on them and so on, right? You don't have to worry about allocating stack space and things. They're just a little bit more full-fledged and definitely more of a more modern object-oriented feature. Structs go back to the old days of like C and other older programming languages, and they still exist for good reasons, but we're going to be using mostly classes. In general, classes are used to model more complex behavior or data that is intended to be modified after a class object is created, and it's supposed to persist. It's supposed to be around as long as the program is running. Structure best suited for small data structures that are temporarily needed. They wind up being passed by values, so they're kind of, you know, they have some other overhead and things on them, but let's not worry about struct so much. But if you see struct and class, you can kind of, you know that they're both different blueprints for some sort of data structure. All right, I don't recommend you use structs unless you have already had a bunch of experience with C#. There's really not a lot of reason to use structs casually, you know, to get into the kind of maybe performance programming. You'll see, like in here, a little bit of example. Structs are sort of a little sibling of classes. Use them for small objects that if you want to use them locally, spin, you know, up on the stack, because maybe, you know, you're just using them within the context of this function or something like that. But, you know, they're there. They look an awful lot like classes, but they're usually just used for performance, convenience, style sake. So if you're looking through an example, you see an example of it on some tutorial, just apply basically what you know about classes to them, and it'll make a reasonable amount of sense. All right, with that in mind, you will see this in other C# resources. So I kind of like to warn you about things you might encounter that are going to sound, you know, really weird like that. Structs, whatever. So there's some great resources. Obviously, Unity has Learning C# in Unity for beginners, so if you need any backup to things. Or you can always go to the source, docs.microsoft.com, and look for their Intro to C# and their C# tutorials. Lots of good stuff on that. We're not going to be implementing a lot of complex algorithms in our C#. So really, as long as you get the basic semantics of the language and the basic structures, you know, the if, else's, the for loops, the whiles, the conditionals, and so on, we're going to be pretty good. So we're not going to be writing, you know, typically for the objects and things that we're going to use, we're not going to be writing hundreds of lines of code and using lots of advanced features. If you find yourself doing that, it's definitely beyond the scope, probably beyond the scope of what you need to do for this class. All right, this class meaning 2540, GSASS 2440, not C# classes. Anyway, okay, bad pun. What's different about using C# inside Unity versus on its own? In other words, what's different about scripting versus writing a program in C#? Okay, in Unity, we're going to be writing components, not programs. So if we were writing something from scratch, we would actually define a class that was the program that had a main entry point. So when the program executed, it would start there and it would accept arguments from the system and so on, and it would be, you know, a real application, right? So we're not writing an application. We are writing components that are going to be called by the engine, right? We're going to have components that can fit in according to agreed upon the event system, the structures, and so on and so forth, right? So we're writing 99 times out of 100, we're going to be writing components. And in order to create a component, we're going to start with the template that Unity provides. Anytime we say, write a new script, give me a new script, it's going to give you this little code snippet here, which is going to name the component with whatever you named the file. This should have a capital in front of it. We'll talk about camel case in a moment, right? So you're going to name your component, and then it is going to, and for now, this is, you just take my word for what I'm saying here. It is deriving from, that's what this little, you know, we're inheriting from, that's what this little colon means here, inheriting from the mono behavior, which is the master, you know, it's going to be the root class for the components that we create, and really is the root class for all of the components that Unity uses, right? By default, it's going to give you two methods, or two methods that are called in response to an event or to events. One method is called in response to the start event, which basically means when you press play in the Unity editor or your game actually starts, your script will be called, this start command will happen. It'll call that method, that start method. And if your game was a real-time game, and we're not going to use the update function in our first program, so that's the first clue to how you should, if you're used to working in Unity, don't use an update. You should not need to be able to use, you should not have to use an update method or event in your text adventure. But that is called when a frame is updated on the screen, when it's time to flip to the next frame or flip to the next animate, whatever it is. Okay, so we don't have to worry about that. So we're going to be writing components, not programs, not applications. We're writing components. They are classes. So we are object-oriented programming. That's us. Components are self-contained classes. They inherit from these mono behaviors that are provided to us by Unity. Components have certain methods that are automatically called at the right time. Those are the events that happen, and those methods get called in response to those events happening, like start and update, and there are going to be many, many more that we also are going to hear about as we get into the physics engine and as we get into collisions and even the user interfaces and so on. Sorry, take a moment. A little bit of drink. So, here's a warning. Compiler errors in components will prevent your game from running. So once you create a script anywhere in your program, anywhere within your project, you have to be careful, right? Unity, especially if it is a component that is used by anything or a script that is used by any component to your game, Unity will think that it needs to make sure that that can compile, that has no errors in it. If you create a component anywhere in your project that has compiler errors in it, just bad syntax and so on, it may prevent your entire game from running, even if you're not using that component or that script in the scene you're working on. So this is a warning. This is kind of a, be careful, right? Once you create a component, once you create a script, it's a real member of your project. So be careful about creating things and forgetting about them, using them, or creating bugs and so. So you have to be a little bit careful. So components, those blueprints, even though you may not be actively using a particular one, Unity's going to be prepared that at any moment maybe you're going to want to use it. So be careful. Right. Now there are other C# structures, other classes, other other things that are not the components that we think of, right? The script components. So Unity uses C# for other things too. There's going to be things like libraries, like math libraries or some of the physics functions, certain math, usually math functions and variables and so on, that are not necessarily based on mono behaviors. There's also going to be some Unity structures like something called a scriptable object, which is more or less a data container, but not a component, right? So there are going to be things that aren't components that don't necessarily inherit from mono behaviors. So don't worry about them just yet, but we'll see them as we start to encounter them. Probably first see things like the math libraries and random functions and things that aren't components of objects, but are still obviously C# functions we can call. And there are some other systems, these entities, components, and systems, which are more advanced topics. They're part of something called the data-oriented technology stack that Unity has been working on for, a few years now, and it's still not quite official. But we're only going to really look at libraries, this whole ECS stack of things, entities, components, systems, different than our components. It's a more complex paradigm. You may have heard about it, so I'll let you down gently here that we're not going to use entity component systems because they're not quite there yet in terms of being official long-term support kind of thing. So we're going to start with the basics, starting with some important syntax and ways of kind of declaring and things and so on. So I like to lead. I think it's good to always lead with comments, documenting your code. Why? Well, it's nice if you know, as part of your design document, you can actually go through and start, sketching out, creating a skeleton of code by just putting comments and saying, okay, here's a function I need, and you put some comments in there to say, I think I need the function to do this, right? So you can actually create design within your scripts, use comments, and you should also be doing things like commenting your code with your feature points indicators so that Justin and I, when it comes time to grade your projects, we'll be able to actually search and find those feature points without having to, lose our minds. If we can't find them, if you haven't commented them, if you haven't indicated where you've done those features, we don't know about them, it may cost you points. So you want to be good about this, right? You don't have to necessarily go overboard with comments, but you want enough comments so that someone can follow your code. Sometimes code will actually be self-explanatory. If you can write very nice, clear, self-explanatory code, there's no reason to duplicate everything to say, if this is y equals x plus b, you don't have to say, the next line is adding x and b and storing it in y, right? There's no reason for that. If you have more to say about what is contained in those or what it's going to be used for later on, well, okay, that's more important to put in the comment, right? So the double slash comment, your most often seen one, that's just going to give you just a single line. It's just anything on there basically goes away after it's compiled, after the Unity engine starts running. It doesn't care what comes after it. That's just there for you and me, for us. Same thing with anything inside of this slash asterisk, right? This is a block comment, more an old style comment. Anything between those two gets ignored, right? Anything between the open and close comment gets ignored, right? Great for longer descriptions. If you want to get real fancy, someday you may see this, you're working for a studio where you have to write code that will then be run through some sort of documentation parser or, system like that. You can actually have sort of a built-in, some markup tools so that your comments will then get pulled out and used for documentation. So if you were writing a Unity library, for example, and you wanted to create documentation so that someone else at your company could use it, you could potentially use this feature in the markup, directly in your code, and then, have it automatically generate documentation for you to use or you to share. Okay. So we had those commenting indicators. The next big structural thing is our use of parentheses, braces, and angle brackets, right? Anything you want to have stuff happening inside of other stuff. Usually we have some kind of indicator, like we had the start and close comments. We also have opening and closing of braces, parentheses, square brackets, and angle brackets. Important stuff. Whew. The first one, everybody's best friend. There's lots of best friends here. The curly braces, or just braces. They are used for creating structure or scope for defining blocks of code and functions. Right? These establish the scope of something, right? So things can be declared locally after the opening brace. They will be forgotten when the scope is closed with that close brace, right? Or if you return from a function, something like that. They basically, anything in there, anything that is local to that, could be local to a function, local to a method. It will be used as long as you are directly inside there, but the moment you leave out that closing curly brace or you return from there, it goes away, right? We're creating local scope using these braces, right? Some sort of scope. Notice that there's scope to the class as well. Like, let's see, we jump back. I'm gonna find here's the class. Here this is the scope of this class, right? Everything between these two belongs to the class. Anything after the start here, you see we have also open and close those braces. This is the scope of this method, right? So things that live in there will also if they're only defined within that scope, they may disappear when they're done. Just like anything that lives that is a property or a field within this class, the moment it is instantiated, it exists. The moment it is destroyed or deconstructed, it goes away. Freed, it goes away. All right. So braces, important for that. Parentheses, they're usually used for calling a function, passing values, right? To indicate that, yes, we're calling a function named so-and-so by having a set of parentheses after it. And usually passing values, they are passed within inside of the parentheses. Pretty straightforward. The square brackets are reserved for accessing elements within collections. We're going to have collections that we can use, like arrays, lists, dictionaries, and some others as well. So whenever you have something that might contain multiple instances of something or multiples of an object, right? You may have an array of enemies. You have a whole bunch of enemies, a whole collection of enemies, and you want to reference them as enemy 0, enemy 1, enemy 2, enemy 3, and so on. You can use a collection like I said, an array or a list and so on, and then use the square brackets to say which element within that collection am I talking about. So that's when we see those. And then angled brackets, right? These greater than, less than, these carets, sort of sideways carets. This is used when we are passing a type to a generic function. That may sound really crazy and esoteric and weird and so on, but it's actually going to become really important relatively quickly. So usually we'll have all sorts of different functions in the engine that sometimes we're not sure, or there may be, one way to say, okay, I want to get a component. I want to get this component of this object. And like we said, components are going to have their own class, their own type. So we may want to ask for a component of a certain type. Give me the text component. Give me the rigid body component. Give me the whatever component of that object. So we're gonna use these generic functions and these angle brackets to say what is the type that we're interested in when it comes to those sorts of operations, right? So we need to find a component of a certain type. We'll use a generic function to get it and specify the type when we ask for it. You'll see. Question. What do you mean by a component of a certain type? Okay, remember when you're creating components, right? Components are classes, and so you define the class, right? It becomes a type. A character controller, a rigid body, a light, a transform. These all are types of components, right? They're all components that live on an object. An object can have any number of different components. You can even have multiple components of the same type, which we have to get tricky with. So we may ask, okay, give me the audio source component of this object, right? And the audio source is the type of the component that we're interested in of that object. Right? So sometimes you'll say, give me, I want to figure out the collider for that object, or like I said, the audio source. You want to change the volume of something that belongs to something. So we might need to do that. So when we need to refer to a component that belongs to another object, we'll often be using these angled brackets to do that. They'll make more sense when you see the examples. Okay. Naming conventions, gotta love these. C#, the Visual Studio, it will actually make suggestions and it will flag errors if you don't do this right. So it's good to pay attention to what they're doing, and it's for good reason. It uses something called camel case, which is, basically we have capitals here that wind up, looking like the lumps or the humps on a camel as we define names. That's where it comes from. We also, Pascal case is a little bit different, but it also uses that same sort of capitalized words within, create these kind of pseudo sentences here. I want to use multiple words within names. It's important to remember that case does matter, right? You can't say in one instance you can't say game object versus game object with lowercase, right? Those aren't the same. Those are quite different things. So capitalization is important. So in our case, we want to capitalize each new word. However, the first word is special. In the case of what we're doing, functions and Unity classes, which are components and so on, those classes start with an uppercase letter. So for example, this is a function, this is a method, this is whatever, would be capitalized. And any component any script should have a capital at the beginning of its name. Any component will have a capital as name. These are the types of those components, though. So let's remember that. These are the types, right? The name of the class, not the name of a specific object, right? Because remember, an object is really a variable of that type of class, right? I may have something called Bob, which is the player game object, right? But a game object is the name of the class, whereas Bob would be the name of a game object. But you'd also have a game object named game object, which is weird, but you would have to name it lowercase game object. You couldn't say game object, that were both exactly the same. That would fail. But you will see situations where Unity itself will have a game object that is named game object, right? Yep, mind-blowing, but it happens, right? Variables, so we want to do this to tell the difference, so we know the difference, right? So if we had a variable, if we had something that actually had held values, a game object that's holding values, chances are it would be a lowercase game object, because variables have lowercase letters as their first letter. And also system types, int, float, public, and system keywords, public, private, those have lowercase first letters, right? So class types should be capitalized, methods and functions should be capitalized at the beginning here, these are the beginning, and then variables and built-in keywords should start with a lowercase. That's the convention. Whoops. So almost all the coding that you're going to do will occur within the scope of a class, except when we're doing scriptable objects and potentially if you want to create your own libraries, right? So for the most part, this is where we're going to live, inside of these mono behaviors. What do you spot that's wrong with this one? Someone point out to me what is wrong with this code. I'll use that as an excuse to have another sip of my beverage. I should give away points, bonus points for people who study the code. What is wrong with it? The class name is not capitalized. Exactly. Is this legal? Will it work? Will it compile? Yes, it will, but it is not complying with the standard. Right, so this M here should be capitalized. Right, so this would be, I wouldn't take off points for this. However, you'll find I will take off points for stuff that doesn't work. And often things like this lead to stuff not working. Do I need a semicolon at the end of a class like C++? No, the scope is that is fine, right? The class itself, don't worry about it, right? You notice we don't have nothing at the end of methods either, right? Okay. Functions manipulate and ultimately are controlled by data, the data that is variables, right? Variables. Variables are interesting because, like I said, we think of them often. We've been talking a lot about the variables that are within classes, but ultimately a object that is created is also data that we refer to through a variable. So it's a little bit weird in that case, but we'll also kind of typically be talking about the variables and data within the class, because that's really the level we typically work in, right? So fundamental data types, fundamental variables, they're declared with a type. C# is usually considered strongly typed, meaning when you have a variable, you should give it a type. There are other languages that can be very loosely or untyped, where you just say, okay, I name something X, and X could contain a string, it could contain an integer, it could contain a float, it could contain an object. It doesn't matter. It can contain anything. That'd be an untyped or loosely typed language. There are ways of doing things like that in C#. I do not recommend them. There'll be certain circumstances where we'll use that, but we like to consider C# and we like to get into practice of being explicit in our typing. right? So if you need an integer, declare an integer. If you need a float, declare a float. If you need a bool, declare a bool. Okay? You can use vars, but I hate to see you using that because it can also it can lead to issues. You want to be careful, right? That's one of the reasons to type your variables so that you know this plus this. You know, you're adding two integers. You're adding your health points to other integers. You don't wind up with half a health point or something like that. Or a string containing a word that you're trying to add to your health. You don't want to do that. So the four fundamental types that we're going to deal with mostly: ints, floats, bools, and strings. Strings are a little bit special in that they have a little bit more functionality in them because they are, they can contain a variable number of characters in them. The others are more kind of atomic or more, they have a fixed size within them, right? An integer stores a non-decimal number. There's no decimal portion, 0, 1, 2, 3, 4, and also negative integers, right? So there's no decimal point here. There's no fractions and so on. We have a question. Or someone typing. Typing is okay. We'll use floats for our decimal numbers, and they always have an F, right? That indicates that this is a float. Why do we do that? If you don't put an F there, C# itself has something called a double. And we could use doubles, but Unity does not use doubles. Unity is float based. Float is all the internal precision is based on floats. So whenever we have decimal numbers, we want to indicate that it is a floating point number, not a double precision number, right? So we want to be explicit. F here. You may, at some point, you probably forget. You'll put it, and then you'll see a warning message in the console saying, error, converting from double, implied conversion from double to float if possible, or sometimes it'll just fail and not work, right? So we're using floating point math inside of Unity. That's why we have Fs, right? Otherwise, 1.0 is considered a double precision number if it's not indicated here. Painful, but it's true. We have bools, which are simple, sort of the simplest data structure, the simplest variable type, in that they are either true or false. They're either right or wrong, right? They're either, you can kind of think of them as 0 and 1, but, that's all there is to it. They have a binary state. They are a Boolean value. They're true or false. Like I said, strings, a little more complicated, used to store a sort of an array of characters that form a string. You can have spaces in them, you can have special characters in them, and so on. So sequences of text characters. And then, of course, we have our classes. Like, classes are variables. They are a class. You can declare a variable of the type of class, like a vector2, a vector3, a game object, a rigid body. Those are compound types. They are defined by us, but we declare variables based on those. Sometimes we'll have to use a special thing called a new. We'll have to call a constructor. They're a little bit fancier in terms of setting them up. Are they mutable? Let's not get too sidetracked on too many things. Okay, I'll talk about conversions in a minute, but let's not get too sidetracked on things. All right, try to not confuse everybody too much. So structured like classes, but they are on the stack. But they wind up being declared the same way. Once you've defined a struct, you can declare variables of that type. It just means they'll be usually used for local space like that. All right. There's always someone who asks me anyway. Creating data, declaring variables, the primitive, easy version. All right. So to declare a variable, we declare it, we give it a type, we give it a name. So here's a nice properly formed one. It is a type of integer. It is health points, good old HP, right? Health points, it's lowercase because it's a variable. And here we provide also an assignment operator, equals the assignment operator. So in addition to declaring it, we are doing an assignment as part of this declaration. So we declare it, we have an assignment, we set its value to be 5, at this point during declaration, it could then be changed. It's not a constant, it's just a integer. It's not read-only. And got all sorts of special ways we could sort of decorate these things, but for now, this is the simple primitive version. Int health points equals 5, and then we have the end of line, right? End of the statement, end. It works, everything here. Or you could have just declared it, declare int health points, and that's going to set it to its default value. Usually that's just 0. In the case of an int, it would be 0. So int health points without setting in an initial value. And then at any point after that, you can assign, use the assignment operator, equals our assignment operator, set it to equals to something. When you have classes, you have to declare them a little bit differently, especially if you initialize them, right? Because they are referred to by reference as opposed to if you declare an integer here, it's there, right? Int health points equals 5, right? It is automatically instantiated. It's automatically there. In the case of a class like vector2, vector3, and other ones, you'll see this syntax being used where you declare it. This part looks okay. Vector my position. This is really not declaring a vector2, but declaring a what we call a reference to a vector2. Right? After it's set up, it's going to look an awful lot like any other reference, but it's or any other variable we're using here, but it's a little bit subtle here. Oh, here. So vector2 my position, that's actually the name, and we can use it to reference it. This is how we identify the object. But in order to really have an object, for that name to refer to a real object, we have to have either an existing object, which maybe the system provides for us for some reason, or we declare a new object of that type. So you see this new operation here, right? This says give me a new vector2, and it's going to have some initialization for it. Right? So it's a little bit different than our built-in types because it's going to have something called a constructor. Right? Classes will usually, well, if they need to do any kind of initialization, they'll have a constructor method. Right? This is the vector2 constructor that takes 2 floating point numbers and it creates all the internal goodness and makes the assignment and gives us a reference to a real object there. Okay? So vector2, vector3, good example of classes that we'll use. And so after it's declared and we get an instance, so we have a valid reference to a position, to a vector2, we can then make assignments to the different parts of the vector. A vector2 has an x component and a y component, for example. We could set those to be 0 and 0. Initially, they're 2 and 3. So x would be 2, y would be 3. We're going to come down here and say, okay, I'm going to change it. My position now is 0, 0. So I put it in the quote-unquote center of the world, perhaps. And then you could do things like add a new vector2, yet another vector2 to this position, right? So, modify the position of my position by adding values, add to the x and add to the y. Right? So whenever you're referencing a class, you may have to use the new, you may have to create a new version to invoke the constructor and get a reference to that. Okay, so we'll discuss that a lot more later. You really don't even need to use those within the first project, but they're worth knowing about. Now, scope. These are attributes of potential attributes of a variable or even of a method. Okay. Whenever you declare something within a class, you implicitly or explicitly give it scope, right? And what scope means is what can see it, within what range can it be seen. Remember before we had those parentheses, or the braces that established the scope, some sort of local scope with regards to code, kind of our code structure. And this is scope with regards to the overall state here, right? We can declare something to be public, which means it is global in scope and means it can be accessed from anywhere in the current script or by any other script. It basically opens it up to the rest of the world to be seen, right? So if we declared our brake calipers to be public, that would mean that anyone can get to them, right? Unlike an Apple computer where you have to be Apple certified to get inside. The DRAM in a Windows computer would be public as opposed to I don't know. Sorry, making a joke. I love Apple computers. I don't know why I'm picking on them. So public is global in scope and accessible through everything. It is not the default. You must explicitly send something to public. The idea being that good practice is that you only make things public that are absolutely necessary to be public, right? To avoid accidentally giving more power to the outside world than necessary. Private is the limited scope. It's accessible only from within the script or only within a certain function. This is what is assumed by default. Wow, how long has that typo lived there? All right, good thing I'm getting new glasses. Assumed by default. So if you don't declare something to be private or public, it will be private by default. So here's some examples. Public int foo equals 10. So everything, if we declared this as a class, attribute or class, property or class, even if you think of it as a field, but if you said public int foo, other things, other classes, other code can see that from outside of this class. As opposed to if we said int bar or private float foof, these things would be private and would only be accessible within our script. Right. Public fields. There's another magic reason to use public, and this is the single biggest cause of unnecessary public variables in C# in Unity. If you want fields or data to be accessible in the Unity editor, because you can do that, you can make your script's variables accessible by the Unity editor. You have to declare them, or one way of doing it, the easy way of doing it is to declare them public. The moment something is public, it means, in addition to other classes seeing it, it means the Unity editor can see it. And that's kind of cool because then you can change those values right there in the editor, right? This will effectively override any initial value. So if you had said public float temperature equals 50, and then later on, because it was exposed to the Unity editor, you changed it, it would then be Unity sneaking in a new value after the compiler set it to 50. You would set it to whatever the Unity decided before start was being called, right? So it's another way to initialize variables inside the Unity editor, but be careful about that. We'll talk about serializable later on, which is a better way of doing this that doesn't make things public, but we'll abuse public for just a little while. There's other things you can do when you declare variables that you can instrument them or decorate them from your code so that the Unity editor will do fancy things with them as well, like have tooltips or have a range, because in this case, if it's float here, maybe you have, this slider, which would be from 0 to 100, right? How do you specify it so specifically which gets set? I'm not sure exactly what you mean, so maybe we'll just do an example. So over here inside of our game manager, yes, you can do it with private. Okay, here's what I'll do. So one way I would say is I could do public int x equals 5. And here I'm going to do serialize field and leave that, okay? So this effectively already says private. Okay, so notice I have public int 5, and then I have private int y equals 10, but this one is serialize field. So it's going to compile, and as long as I have no errors, it will get past here. And you'll see it. We'll refresh this. Let's go to Game Manager. And now we see x equals 5 and y equals 10. And I can change both of those. If I set this to 15 and I set this to 10, those are going to be the values when it runs. The bad news is that it's not going to change it in the code here, but it's going to change it right before start or before any, after this initialization, but before any events get called. So that's going to be a little bit weird. So be careful about that. If you know something is going to be set by the Unity editor, just, I don't know, be careful. Go back to 10. And what was it? Tooltip. This is private. Whoops. All right. This is public. This is private. I can scroll it here. That's something we do with just all of them. But I could, go ahead and put the range if I wanted, and so on and so on. Okay, let's leave that as B. All right. So that's one cool thing that we do it. But remember, you can either make things public or use serialized field, which is leaving them private but making them accessible and editable to the Unity editor. So it's kind of preferable to use serialized field as you get more comfortable with that. So as you're programming, it's good to know about operators and operations, right? You want to do stuff. You want to, assignments are great and all, but you probably want to do more than just set numbers equal to numbers or variables equal to some initial values. So we have some basics, arithmetic operators. Hopefully these are pretty straightforward. We're used to addition, subtraction, multiplication, and division at least. And the syntax is pretty easy in that we have an assignment. So we have a variable and we'll have an assignment. And then we'll have the operation that is a combination of operands, like x and y here are the operands, and the plus is the operator, right? So x plus y, they will execute from right to left. They will use our standard parentheses. If you have lots of parentheses used to kind of group operations, the innermost parentheses will get run first. Multiplication happens before addition when it's ambiguous. So just remember that good old Purdy rule. I forget that is Purdy. What was the name of the rule, wasn't it? Anyway, so the one you may not have seen before, and the one where it's also one where it gets a little bit odd here. 10 divided by 5, that's pretty obvious to 2. But what if you're doing integer-based division and you said 11 divided by 5? Right? So for those of you who haven't encountered this before, 11 divided by 5. In the case of an integer operation, that is still 2, right? Because it does not have the ability to hold a decimal. It doesn't have to, the fractional piece gets thrown away. So if these were integer numbers here and I had said int x, y, 11 and 5 and divided the 2, I would get 2. We have a handy operator called the modulo operator, mod, which allows us to calculate the remainder though. So we can figure out what happened. So if I had 11 mod 5, for example, 11 mod 5 would evaluate to 1, just like 16 mod 3 would evaluate to 1. Because 16 divided by 3 would give us 5, right? That would be the whole portion. And then 16 mod 3 would give us the remainder, which is 1. That comes in handy for, say you want to figure out, you have a day from 0 to 365. and you wanted to figure out what day of the week it was. You could do day mod 7, which will then give you a number 0 through 6 for the remainder, right? The remainder will be 0 through 6. So you know if 0, it's Monday, 1 is Tuesday, or yeah, however your convention is, 0 Sunday, 0 Monday, you know, it goes after 0, 1, 2, 3, 4, 5, Sunday, Monday, 2, 3, so on. Right? So that's what mod is for. Very useful for that sort of thing. So if you need to say, well, give me the 5th element, or you want to put things in rows of 5, or things like that. Okay. So next type of operators, the relational operators, which are also handy as we get into conditional operations, right? So if you're not sure, do you want to do this, or you want to set some condition for something to happen, right? Print something on the screen if distance is less than 2, right? So if you're getting really close to something, distance is less than 2, or if hit points equals 0, right? We're going to use things like this. So relational operators are used to check the relationship between two operands. If the relationship is true, the result that's passed back is true. Otherwise, it will result in false. So notice we have double equals. If we just use a single equals, that is an assignment. So be careful, especially when you're checking a condition. You want to say, if this equals this, then run some chunk of code. Be careful not to accidentally put an assignment in there. That's why we have an explicit double equals to check equality as opposed to using the same equals. That would be bad. So we have equals, we have greater than, so whatever's on the left-hand side being greater than the right-hand side, less than, greater than or equal to, less than or equal to, and also bang equals. So bang, or exclamation point, is our simple way of saying not, or not, false, whatever. Not equal to, the opposite of equal, right? Not equals. Relational operators are used in decision making and in loops as well. So we introduced this concept of true and false, and you can, in some cases, maybe you'll just have Boolean things where you say, okay, is the ship red? And the where was I going with that? Is the ship dead? Is the ship false? Is the door open? There we go. The door is either open. It's true or false. So open. We have a variable, a bool called open. So you could say something like, if open, do something. If not open, don't do something, right? So there we have so you might have something to say, if open and moving, or if open, or if unlocked and closed, if closed and locked, right? You may have situations where you have some kind of condition that the door is in, some kind of state that the door is in that's either true or false. So can you use double bar and double and, or do you use and or? You use the double bar and double ampersand. You don't use and or, right? You use the symbols there. Okay, so logical operations used to perform logical operations such as and or, and they operate on Boolean expressions or the result of conditionals, right? So these conditionals return a Boolean value, so we can use those to create these complex conditions. We said this is greater than that, and this is less than that. So if health points is greater than 0 and holding the sword, right? Holding the sword might be a Boolean. It might be holding the sword and powered up, right? Imagine that, those sort of operations. So or just means one or the other. If both of them are true, that means both of them are true. This or that. If you said true or false, that's one or the other, so that's true. And true and false, something cannot be true and false, so therefore that would be false. And in the case of false and false, that always returns false, right? Two wrongs do not make a right. False and false does not make a true. So a lot of the time, these conditionals, we'll be using them to check should something happen? Should a condition end? Should a loop end? How many times should we run something? And just, what is the current state? And especially in your first game, you're going to be saying, okay, if I bump into a wall, if the distance is less than 5, if I've run out of health points, if the key and I are within a certain distance of one another, if I'm holding the key and I reach the door, right? So here's a simple introduction to these conditionals. If, and then in parentheses, it's kind of like, it's kind of like a function. Think of if as a function, returning the evaluation of this logical statement. Kind of almost think of if as a function, kind of. So if it's night, if night evaluates to true, then you would do what's in the scope of these parentheses. The parentheses are actually sort of optional, as long as it's just a single line of code that is being run in reaction to that condition. But I recommend, until you get more comfortable with things, until you get more experience with things, be explicit, and if and else statements, go ahead and put these parentheses in just to get, or get these braces in just to get into good habits, just in case. I've seen lots and lots of bugs where people left them out and really didn't mean to do that, especially as they got into debugging and caused problems. So in this case, it's a pretty dumb piece of code because night is being set to false immediately here. Yeah, they're optional if you only have one line in the body. That is true. But be careful. Be careful when you do that. I've seen so many people where they're like, oh, I need to debug something. And they add that one extra line to do a print. And suddenly nothing works because it breaks things. Because now you have 2 lines of code and you didn't put in your braces. So for starters, I recommend putting braces in. Right? So in this case, we have if night, else. What are you worried about? Because we don't worry about things. We only worry at nighttime. We don't worry during the day. So if night, print it's night. If else, else. What are you worried about? There is no then. It's just if night and else. So if and else. Output of this code. What are you worried about? We also have these what are called the unary operators. There's lots of other operators that are largely kind of shortcuts to other ones. And some of them, well, if we want to manipulate the sign of a value, in other words, make things positive or negative, or do things, simple operations like increment and decrement, which is basically the same thing as adding 1 or subtracting 1 from something. But we have a shorthand for it. It's how C++, the language, got its name, because it was an incremental increase, an incremental improvement from C, right? C++, get it? C#, who knows? That's kind of a cool name. I don't know why. Anyway, so these unary operators mean basically they can operate on a single value. So you can increment a value. This is also known as post-increment. You could pre-increment as well, which is to put the plus in front. Be careful with, just kind of the order in which happens. C minus, that's going to reduce it by 1. And then you can do things like negations on a variable, and you can also do things like negate the sign, invert the sign of an operand. So give you the negative of that. A negative of a negative is positive, right? It's a great way to flip the positive and negative, and also to flip, make true false and make false true, right? Introduce this one as a watch out for it in case you see them. The wild ternary operator. If you see it out there, it's also known as an embedded conditional execution. So if you have a variable and you see equals, there's a conditional statement, a question mark, and then 2 expressions separated by a colon, that means it's sort of a built-in if structure in here. So it says, okay, evaluate this condition. If it's true, do this. If it's not true, do this, right? It's kind of fancy. It's kind of a sneaky way to put in an if statement inside of an assignment, right? Sort of a conditional assignment here. Conditional execution or conditional assignment. Bitwise shifts sometimes, and as we get into some of the more advanced features of layers and layer masks in Unity, we're going to be doing things where we're performing bitwise operations. So sometimes we'll have a field that will just get down to really manipulating the individual ones and zeros inside of. And we have special operators for those, and that's where we reserve that single ampersand and the single bar. So I really just introduced them here because it's easy to confuse some of these with the others. Like this isn't really, really less than, or really, really greater than, or just and or. These are the bitwise manipulations, so be aware that they exist, and this is why you don't want to use really, really greater than, really, really less than, and simple, what looks like a simple and an or, because those are reserved for bitwise operations. And then we have some ways of, as you get fancy, as you start to, develop your own style, compound assignments, right? Or again, there's shortcuts to doing other things. If you wanted to do x equals x plus 5, you could just say x plus equals 5, right? If you wanted to say x plus plus, we have lots of ways to say x plus plus now. We could say x plus equals 1. We could say x equals x plus 1. We could say x plus plus, right? Tomato, tomato, lots of different ways to pronounce it, to do different things, right? Even mod, bitwise operations, and so on. Be aware there's something called lambda operations, right? You may remember the get, someone was asking about the arrow in there. That was actually a lambda operation because it was just a single operation. That's a fancy thing. Lambda operators are kind of fancy when you want to just basically substitute this code in for everywhere this appears. It's kind of like a macro, but don't just forget I said that unless you were the one asking about that specific syntax before, all right? So that was actually a lambda operation, which is why you can get away with that. When you have a single line of code you want to sneak in somewhere, sometimes you use lambda operators to do that. Fancy. There are ways we have to be it's a good idea to be reasonably explicit when it comes to converting values. Sometimes Unity and C# will just do it for us. So often when we're constructing strings, we want to say like, oh, health equals so-and-so, high score equals so-and-so. A lot of the time you can just say string equals, and as long as you have some portion of that, or it starts off as a string plus some integer, it'll kind of convert and do the right thing. So this method one here is often the one we use. So if we want to use HP equals or HP colon number, you could do that. Simplest way over here. Whereas if you said, oh, okay, I just want to set it to the number 5, you might want to be more explicit. And this is where we kind of expose that even something like 5 is a variable that actually does potentially have methods that we can invoke on it. So we could convert the number 5 to a string, right? There's actually functions to do that. So we also have within the different types, they have some built-in, and these are called class methods or type methods, where we can call certain functions, in this case the ones that just parse from strings to the actual normal intrinsic values. So sometimes objects will have kind of other built-in methods that, a lot of time we'll just think of these as being, bools, ints, floats, but they really are, you have to remember that within an object-oriented system, we can potentially even do things like this, right? Have conversions, have all sorts of overridden features and capabilities and behaviors, right? In there, all right. So I'm going to reserve a slight bit of time here. So we're going to get even more barrel into things here on Friday. But let's look at a little bit of code in here, because what I want you to do as an exercise to start playing around, you've got your scene here. You should have a game manager object. And I want you to start to feel comfortable just doing some simple math, try out some things, try out what we've discussed so far here. So you want to have a game manager object, and then on that, create yourself a game manager script, and we can create, so start is really the one, think of that as being sort of the main function for now of our components, right? Because we can count on that being run when the game starts here, right? So what I've done inside here, just as an example, and I want you to think about this, is imagine within this class, I had some operation that is important to me. It's called add for some reason. So I create this add method, right? So this is a method of the class called add. And anytime add gets called, it's going to add x and y and assign the results to x for some reason, right? So every time add is called, it's going to add, basically in this case, since it's x equals x plus y, the first time around, x is 5, and the first time around, y is 10. So the first time add is called, this is 5, this is 10. The result will be 15. And it will print 15. And it will return. Oh, no, it won't print 15. It'll print z. I'm going to comment that out. Z is just the result over here. Oh, okay. Well, I could print Z. That's okay. It's going to be a little bit weird. Z is going to be the value before this gets called. Oh, what was I thinking? Let's do this. We'll put it here. All right. There we go. And this I wanted to demonstrate a little bit of the scope here, right? These variables here, these are now class variables. We could, sometimes, like I said, this one's public, so we could almost consider this one to be a property. Now this one, we're in this gray area where it's accessible by the Unity editor, but it is private, so it's more like a field. And this one's truly private, so we can think of this as being a field within the class. But these are all scoped at the class level. So we have public, class, game manager, and they're up here. So these variables can be accessed by any method within the class. And they exist for as long as this object exists. So if I call add and then print out the result, the next time I call add, it will use the new values that I just calculated because they are at this class scope here. So let's save that. And we'll come over here and we'll see the result. And I really just want you to, it's 350. So try out some things. Try out your code, and you'll see it here. So we had 15, and the next time around it was 20 because we added another 5 to it. Oh. Important tip of the day. Most important thing. You'll notice when I press this, my whole Unity editor got this orange tint. So don't leave yet. I apologize. And it's important to note when you're running in Unity, the moment you hit play, you can continue to edit things. You can even come in here and go to the game manager and change these values, right? But the bad thing is, notice I changed it to 145. I stop the game, it jumps back to 10. My changes go away. So I did it personally, lots and lots of times where you go in, you think you're changing something, and then you realize, oh my God, I left Unity in play mode. So therefore, everything is about to go away the moment I hit stop. So there's a handy way. Go to Edit, Preferences, Colors, and you'll see that there is a play mode tint. And choose this. I'm going to go back to my kind of bluish here. So that once you go into play mode, Unity will change its color here. Right? It'll tint the background so that you know explicitly that you are in play mode. And anything that you edit will go away, will revert the moment you get out of play mode. So that's public service announcement for the day, important thing to have. On that note, it's 3:50. Thank you, or 3:52. I apologize for the 2 extra minutes of your time. Good luck. I look forward to seeing the results of your designs tomorrow. and I'll try to get some feedback as quickly as possible. We'll see how it goes. We've got a lot of students in the class, so we'll see whether or not we get them before Friday. Otherwise, have a great day, have a great Wednesday, Thursday, and see you on Friday. If you have questions, I'll be around. Post your questions. Happy to help.